Hello friends, let's see an interesting application of Laplace transform, that is to solve differential equations. As we know, differential equations are used to describe the systems. Even impulse response is used to describe the system. Here in this problem we can see application of Laplace transform to solve the differential equation and get the impulse response from it. So let's see the problem. Determine all possible impulse responses of the system given by this differential equation. So let's see the solution. So given differential equation is d2 by dt square y of t plus 2 dy of t by dt minus 3y of t is equal to x of t. Let's take Laplace transform of both the sides. Now we can use here differential property, that is differentiation in time of Laplace transform, where if we take single derivative, effect in s domain will be x of s or y of s will be multiplied by 1 time s. So as here you can see the first term, it is second derivative, you can see here it is multiplied by s square into y of s plus 2. Here it is single derivative, so it is multiplied by s into y of s, which is Laplace of y of t, minus 3 into y of t is Laplace y of s is equal to x of t is Laplace x of s. We can combine or take common y of s so that we can write s terms together. So it will be y of s into s square plus 2s minus 3 is equal to x of s. As I am interested to find out impulse response, so I can write this y of s divided by this x of s, which will be 1 divided by this term goes here s square plus 2s minus 3. But I know y of s divided by x of s is equal to h of s, which is equal to, I can describe by taking roots of this. So you can directly take if it is possible, or you can use a basic equation, that is minus b plus or minus under root of b square minus 4ac divided by 2a. So you can use that equation to find out the roots. Here as it is direct, minus 3 that can be written as plus 3 in minus 1, which will give you sum as 2s. So h of s will have, or this polynomial will have the factors like s plus 3 and s minus 1. We have to find out its inverse Laplace by using partial fraction method. So we represent this as sum of two independent terms, and that is written as a upon s plus 3 plus b upon s minus 1. Now we have to find out the values of these coefficients a and b. So how a is obtained? So value of a is equal to the corresponding factor s plus 3, here it is s plus 3 into x of s, and this product has to be evaluated for s is equal to minus 3. So s plus 3 into, let's write x of s as it is, and we know x of s in this case, you please consider h of s. So this is h of s in our problem, 1 upon s plus 3 into s minus 1, which is to be evaluated for the value of s is equal to minus 3. This s plus 3 and this s plus 3 will get cancelled, and what is remaining is 1 upon s minus 1, which is to be evaluated for s is equal to minus 3. If we substitute s is equal to minus 3 here, minus 3 minus 1, the answer comes minus 1 by 4, and thus the value of a, that becomes minus 1 by 4. Similarly, we can calculate value of b. b is equal to, the corresponding factor is s minus 1 into that h of s or x of s. So it is 1 upon s plus 3 into s minus 1. So this s minus 1 and this s minus 1 will get cancelled, and we have to evaluate this for value of s is equal to 1. So after that cancellation, what is remaining is 1 upon s plus 3, where we have to substitute s is equal to 1, and thus this gives the value for b, which is equal to 1 by 4. So we have this value of a and b as minus 1 by 4 and plus 1 by 4 respectively. Let's substitute to get the equation of h of s in terms of some simple form or simple summation form. Why we do this? Because we will easily get inverse Laplace of this. Instead of product terms, if we represent this as sum of two terms, we can find out Laplace easily. So let's take inverse Laplace, and as we know, if we see here term s minus 1, that means there is some e to the power term is going to come into the picture in time domain. So 1 by 4, as 1 by 4 is constant here, that will be as it is in s domain or in time domain. S minus 1 is, this minus 1 is the factor because of e to the power t plus t, and 1 by s is Laplace of u of t. So inverse Laplace of this term becomes 1 by 4 e to the power t u of t minus, as it is, minus 1 by 4 is the constant term as it is, s plus 3 here, so you can very well know what is the corresponding term in time domain, which is adding this plus 3 effect to s is e to the power minus 3t. So please note here, if it is plus, this should be minus, and u of t, whose Laplace is actually this 1 by s. I have written this Laplace or inverse Laplace by considering all terms are causal. That means ROC, that is the real part of s, will be towards positive side. There are two possibilities with respect to this. ROC in this case will be s greater than 1, and for this case s greater than minus 3. But if we consider all terms causal, means this will give you right-sided ROC, this will give you right-sided ROC, and as per the properties of ROC, the overall ROC will be right to the rightmost pole, and that's why if we consider all the terms are causal, ROC will be greater than 1, that is towards the right side. So this is one of the possible impulse response. There is also another possibility if I consider all these terms are non-causal, and if all these terms are non-causal, that means ROC will be towards left hand side for this term also and for this term also. So ROC towards left hand side means s, that should be less than 1, and here s should be less than 3, and if we consider the combined ROC, it will be the left of leftmost pole, and we have the leftmost pole at s is equal to minus 3. So your sequence, resulting sequence of h of t will be a left-sided sequence, and that's why this inverse Laplace becomes minus 1 by 4. It is, you can note here the change is minus e to the power t as it is and u of minus t. So this is left-sided sequence, and that's why you can see this minus and this minus is coming into the picture, which indicates it is a left-sided signal. Similarly, I need to find out inverse Laplace of this, and which should satisfy the ROC as my left of minus 3, and that's why 1 by 4 constant as it is minus as it is negative sign and u of minus t. So u of minus t you can see here, and that negative and original negative sign will make here positive. Thus, if all the terms are non-causal, your h of t will be having left-sided signal. That can be very well seen from this u of minus t and this minus sign which is involved here. There is another possibility of ROC where that ROC will be in between minus 3 to 1. That means this ROC should be right hand sided for this minus 3 pole, and this should be for left hand sided for this pole at 1. So the corresponding inverse Laplace transform will be minus 1 by 4 e to the power 3t u of t. This is for right-sided u of t, so this is for less than 1, and minus 1 by 4, this is as left-sided, which is less than 3. So this is the ROC, which is a band in between minus 3 to 1, and its corresponding impulse response that you can see. One term is right-sided signal, another is left-sided signal, and combination of these two will be the final h of t. And there is another possibility where real part of s is greater than minus 3 and real part of s which is also greater than 1. But if you see this real part of s greater than minus 3 means this is left sided ROC, this is greater than 1 means this is right sided ROC, and this is not a continuous region. And one of the most important property of ROC, that ROC must be a continuous region,